It is a fragment of deep time, yet its worth is measured in the currency of today. The highest price ever commanded by a single diamond surpassed 71 million US dollars, a sum capable of acquiring more than 1,400 Rolls-Royce Phantoms, the very definition of automotive luxury. But its claim to eternity is not rooted in its price. It is forged in a unique crystal structure that grants it near unbreakable hardness. These stones are relics from a time long past, formed billions of years ago under the most extreme conditions imaginable, deep within the Earth's mantle. Pulled from the depths as raw rock, each stone endures a brutal transformation. It is crushed, filtered, and sorted before being meticulously cut and polished with almost perfect precision. Only after passing the strictest quality inspections can it become a coveted piece of jewelry or a critical component in high-technology industries. The journey of a diamond, however, extends beyond its geological origins and into the realm of human perception. A pivotal moment arrived in 1947 when the De Beers Company unveiled its iconic slogan, "A diamond is forever." This was more than just a successful advertising campaign. It fundamentally reshaped how the world saw these gems. From this campaign, the very idea of proposing with a diamond ring was born, spreading across the globe to become a deeply embedded cultural tradition. Some wedding ring brands even took this exclusivity to an extreme, instituting a unique policy where each customer was permitted to purchase only one ring in their lifetime. Today, the story of the diamond continues to evolve, driven by technological innovation. No longer confined to being mined from the earth, these stones can now be grown from the ashes of departed loved ones. Pioneering companies such as Algor Danza in Switzerland have mastered a process using high-pressure, high-temperature technology to transform carbon from cremated remains into memorial diamonds. For many, this represents a profoundly moving and elegant way to keep a loved one's memory alive forever. Here, science and human emotion converge, creating one of the most beautiful forms that nature, and now humanity, can offer. Before it ever catches the light, a diamond is born in absolute darkness. It is a child of chaos, forged in an environment so hostile it defies imagination. Deep within the earth, temperatures soar to 1,000 degrees Celsius, while the weight of the world above generates pressures exceeding 50,000 atmospheres. In this crucible, carbon atoms, among the planet's most fundamental elements, are subjected to such intense compression that their very structure is reborn. Their molecular bonds realign, locking into the famously strong and stable crystal lattice that we recognize as diamond. Yet this extraordinary transformation hangs on a knife's edge. The slightest deviation, a minor drop in pressure or temperature, and the process fails. Instead of a diamond, the carbon becomes simple graphite, the soft gray material found within a pencil. This delicate balance dictates that true diamonds can only form in the deepest, most ancient and stable regions of the Earth's mantle. After slumbering for millions of years, a rare few of these stones are violently thrust toward the world above. They are carried on ancient volcanic eruptions, racing upward through vertical channels of magma until they are trapped within a special type of rock called kimberlite. It is here that the human search begins, uncovering treasures formed between 1 and 3 billion years ago, now resting just beneath the surface, waiting for their story to continue. A whisper in the earth, a shadow on a satellite map. The hunt begins with the faintest of clues. To pinpoint potential mining sites, geologists become detectives, piecing together evidence from a vast array of advanced data sources. From high above, satellite images reveal strange patterns on the surface, while gravity sensors register subtle shifts in subterranean density. Magnetometers trace magnetic anomalies, all pointing toward the deep rock formations where diamonds might lie. At times, the only sign is a single misplaced fragment of kimberlite, the volcanic host rock, found glinting in the surface gravel. This lone clue can trigger an exhaustive survey of the entire region. Where deposits are found, colossal open-pit mines spiral down into the earth, vast man-made canyons stretching over a kilometer wide and plunging nearly 500 meters deep. Before every blast, dozens of powerful drills bore into the rock face to prepare cavities for explosives. With the detonation, the earth shudders, and the fractured stone is scooped into massive haul trucks, beginning its slow ascent to the surface for processing. But when the gems lie deeper, or the landscape forbids such massive excavations, the operation must turn inward. Here, miners descend into a labyrinth of narrow passages, sometimes reaching 700 to 800 meters below the surface. They work in a world of oppressive heat, humidity, and dim light, where every move is governed by strict safety protocols. This monumental effort, from analyzing satellite data to excavating the deep earth, is all for a prize of incredible rarity. On average, a staggering 250 tons of rock must be moved and processed to uncover a single carat of diamond, a crystal scarcely larger than a pencil's tip. Once the blast-fractured rock arrives from the depths, it is immediately funneled toward the crushing system. This marks the first mechanical step in liberating one of the planet's most coveted minerals from its stone prison. Here, immense crushing machines, weighing tens of tons apiece, act as relentless steel jaws, capable of pulverizing even granite, one of the hardest natural stones on Earth. Yet for all their legendary hardness, diamonds possess a fatal flaw. They are exceptionally brittle. A single, poorly aimed impact can instantly shatter a priceless crystal into worthless dust, erasing its commercial and aesthetic value forever. Because of this paradox, the crushing force is a delicate balancing act. It must be powerful enough to obliterate the surrounding rock, yet gentle enough to leave the hidden diamonds unscathed. In modern facilities, this is a multi-stage affair, starting with slow compression from heavy rollers, moving to rolling crushers for further reduction, and concluding with vibrating separators, each stage meticulously calibrated for efficiency and preservation. With the rock now reduced to smaller fragments, the entire mixture proceeds to a crucial cleaning phase. This stage is vital, as the ore is heavily contaminated with clay, mud, fine dust, and natural adhesives from deep within the earth. Left unchecked, this slurry of debris would clog the delicate machinery, accelerate wear on the equipment, and compromise the advanced separation systems that follow. To combat this, the material is subjected to an industrial-scale washing, passing through large rotating drums, multi-level vibrating screens, and under the force of high-pressure water jets. The aggregate is plunged into a swirling torrent of water, which scours away grime while simultaneously filtering out the smallest particles. Any fragment under 1 millimeter in size is discarded here, as the cost of processing it far outweighs the slim chance of finding a diamond within. Once cleansed, the remaining rock is sorted by size, creating a concentrated ore, a refined collection of fragments with a much higher probability of containing diamond crystals. From here, the concentrated ore enters the realm of cutting-edge separation technology. As the stream of material flows past, X-ray fluorescence scanners bathe each fragment in invisible light, searching for the unique, telltale glow that only a diamond emits. The instant a diamond is detected, the system fires a precise, targeted burst of compressed air, deftly blowing the gem out of the main flow of rock in less than a second. This remarkable method separates diamonds with astonishing speed and accuracy, ensuring even the smallest valuable stones are recovered efficiently. Now finally liberated from their stone matrix, the rough diamonds are gathered, ready to enter the preliminary sorting phase. Before its fire can be unlocked, each stone must face its first judgment. This is the preliminary sorting phase, a crucial first step in determining the destiny of every crystal. Experts assess the diamonds based on 4 key criteria: their size, color, clarity, and their inherent natural shape. While modern 3-dimensional scanners and optical tools provide assistance, much of the evaluation still hinges on the trained eyes of skilled craftsmen. These artisans can detect microscopic cracks or subtle color variations that even sophisticated machines might miss. This stage divides the diamonds into 2 main categories. The first group is composed of high-quality stones that meet the rigorous standards for luxury jewelry production. These are the clear, well-shaped diamonds, large enough to be fashioned into desirable pieces. The second group consists of the smaller, misshapen, or heavily included stones. These are typically destined for industrial use, becoming vital components in products like drill bits, cutting tools, or high-performance parts that require extreme hardness. For the diamonds that show commercial potential, the journey does not end here. They undergo a far more detailed evaluation, where specialists analyze their structure and flaws to plan the most efficient and profitable cutting strategy. The goal is to maximize both the economic value and the visual appeal of each stone, turning a rough crystal into a polished gem that captivates with brilliance and symmetry because every single diamond is completely unique. No two stones are ever exactly the same. Within every rough stone lies a hidden fire. The challenge is not to create it, but to release it. Because no two diamonds are ever identical, experts begin by performing a full three-dimensional scan of the rough crystal. This digital model maps its unique shape, its internal flaws and clarity, and the precise way light refracts within its structure. This data is then fed into specialized software, which calculates countless possibilities to find the most efficient and valuable cutting options. Some diamonds are destined to be divided into multiple smaller stones, a strategy that maximizes profit when internal imperfections make a single large gem less viable. Others, particularly those that are exceptionally rare or clear, may be preserved intact to become a one-of-a-kind masterpiece. Every decision is a delicate balancing act, aimed at unlocking the diamond's full potential by harmonizing brilliance, symmetry, color, and weight. The objective is to produce a final stone that sparkles with intensity, displays optimal color, and retains as much mass as possible, all while enhancing a natural beauty that took billions of years to form. Once the evaluation and planning are complete, the rough diamond moves to the crucial steps of cutting and polishing. This transformation starts with a preliminary cut, typically executed with a high-powered laser. With precision measured in thousandths of a millimeter, the laser slices the stone along its weakest structural points, enabling it to be reshaped or divided without causing unwanted cracks. From there, the process advances to the grinding and polishing phase. Skilled artisans press the gem against slowly rotating wheels coated in diamond dust, as only diamond itself possesses the hardness required to shape it. The cutter must carefully adjust pressure, contact angles, and rotation speed to ensure each facet is crafted to the most precise proportions possible. This entire undertaking can last anywhere from 3 to 8 weeks, its duration dictated by the diamond size, its complexity, and the desired standards of quality. The final result is a stone with flawless geometry and brilliantly cut facets, each one designed to reflect light with maximum intensity, creating the dazzling sparkle that gives diamonds their timeless appeal. After being carefully cut and polished, the diamond is sent to its brilliance is undeniable, yet its true identity remains hidden until this final test. The stone now enters a world of intense scrutiny, arriving at a grading laboratory for a comprehensive inspection. Here, experts evaluate the diamond against multiple criteria, assessing its color, clarity, carat weight, and even the most minute internal imperfections. Every detail is meticulously examined under specialized microscopes, ensuring nothing is overlooked. If the diamond meets these exacting quality standards, it receives a microscopic laser inscription. This unique identification number, engraved along the stone's girdle, remains completely invisible to the naked eye and guarantees full transparency and traceability for its entire lifetime. With this process complete, trusted institutions like the Gemological Institute of America, or GIA, and the International Gemological Institute, IGI, issue an official certificate. This document outlines all of the stone's technical specifications and grading results. In essence, it serves as the diamond's passport, a formal verification of its quality and authenticity for the international market. Once certified, the approved diamond is ready to continue its journey into the world of fine jewelry. From the Earth's fiery heart, the stone now enters the steady hands of the artisan. Here, its final destiny takes shape, determined by a design that may see it become the centerpiece of a ring, a pendant on a delicate necklace, a brilliant pair of earrings, or even a standalone work of art. For legendary houses like Cartier, Tiffany & Co. and Harry Winston, the standards are absolute. They demand not only a flawless diamond but also masterful artistry in every detail of its setting, whether forged from lustrous gold, enduring platinum, or precisely blended alloys. Each finished piece is a profound union of nature and human creativity, a gemstone formed billions of years ago, now cradled by the precision of modern craftsmanship. The result is an object of timeless allure, its brilliance amplified by an elegant mount, creating an heirloom meant to be treasured for generations. And while these stones are widely regarded as emblems of purity and eternity, a brilliant sparkle can conceal a dark history. Not every stone begins its journey in the light. Across impoverished landscapes in Africa, from Sierra Leone to the Central African Republic and Angola, the search for diamonds remains a grueling, manual affair. People toil in muddy streams, sifting through silt entirely by hand, their bodies exposed to an unrelenting sun without any form of protective equipment. The hands that perform this labor can belong to anyone, adults and children alike. For countless families, the slimmest hope of uncovering even the smallest gem represents the promise of their next few meals. But the stark reality is a cruel one. A stone destined to be sold for tens of thousands of dollars may leave its digger with nothing more than calloused hands, or worse, a legacy of pure hardship. Yet this crushing weight of poverty is not the only shadow they cast. In certain regions, armed factions have seized control of the mines, channeling the profits from diamond sales directly into funding wars, acquiring weapons, and perpetuating violent conflict. Diamonds sourced from these territories are known as blood diamonds. The name is a literal one, for they are traded at the cost of human sweat, tears, and blood. A dazzling facade that so often hides a story of profound suffering, proving these are far more than just precious minerals. They are the crystallized remnants of human struggle. Behind the fire and brilliance, a silent history waits to be told. These minerals are the physical embodiment of time itself, of immense geological pressure, and of relentless human effort. By tracing this long and arduous journey, our perception of value begins to shift, fostering a deeper appreciation and a more considered approach to the choices we face. It is a powerful reminder that the most extraordinary tales are often held within the objects we see every day, waiting just beneath the surface.